to the next video that we're gonna talk about more in detail about each of these staff policies, each of the algorithms. So let's get started. Uh, right now, for this simulation, we are running with 120 pedestrians, and so for starters, random, as the name suggests, has pedestrians running at a random direction. There is no goal, so it's just random movement for our baseline performance. PSO, I think this is a very fast algorithm, but yeah, so just to briefly explain, all of the pedestrians staff included are pure PSO agents. That is, they know the shortest path and they just take it and go towards the goal. So this is like the best case scenario, which is usually not possible because pedestrians do not always know the right path. And this is the social forces model. Here, the everyone are pedestrians. They're, even though we have color coded it as staff, they are not really staff. They just placeholder colors. But here as well, all of them are just going towards behavior which is herd behavior, and they mimic social forces like repulsive forces, driving force, and an overall force is calculated to find out the velocity of their movement. So this is SFM. So our goal was to find midway between the PSO and SFM, and that's what we're going to see from now on. And moreover, we have tweaked these algorithms with little staff policies to check which policy, that is, what staff could do to have a better evacuation in each scenario. So, for example, what if all the staff evacuate without assisting people? So this is the condition where the yellow color, which is staff here, are evacuating without helping anybody, and the color codes really help us understanding what's happening. The blue are pedestrians, the red are also pedestrians, but they're in panic mode. um, Next, we'll talk about staff all assist. So it's a very flexible policy where all the staff are trying to assist as many people as possible who are around them. But we can see a lot of panicking around doorways and exits because everyone's trying to bottleneck around that. So most bottleneck situations here cause panic. Similar to the previous policy is a half assist, where half of the staff assist and half of them try to evacuate. Even though this seems like a bad one, when staff who are evacuating are seen, there is an underlying herd behavior which allows some of the pedestrians to follow these staff and evacuate themselves automatically. And then the assist mobile, which is an algorithm as flexible as the previous ones, but the staff is selectively going to assist only mobile pedestrians first in by and avoiding elderly people who are essentially slower. And this is assist elderly, which is exact opposite of what we just discussed, which is uh, prioritizing elderly people over mobile pedestrians. The next one is top evac, wherein the priority is to evacuate the top floors, and once that is done, we go to the next floor. So we set up priorities for the floors. So first, staff will try to evacuate the people on their floor, and then they'll try to check if there are people on the top floor. They will go and evacuate them, or they just go to the bottom floors. So that's top evac. Avoid top is a very specific example wherein we're considering that there could be a fire somewhere in the middle floor. So usually what happens is staff will try to avoid going upwards, so it's always going to be a downward movement. So most staff will avoid going to the top floors to help. So that is avoid top. And one of the most rigid staff policy that we can see is going to be the zone sweep. So each staff on initialization, for simplicity's sake, we are having one staff per each room while initializing itself, and they will try to evacuate the people in their zone or the room here. And once they see that there are no people in their zone, they will go and evacuate themselves. So that is the zone sweep. Another one is the MFO SFM and ACO SFM. These are just supplementary algorithms that we've implemented just to see the comparative performance between PSO SFM and these other algorithms. Here, there is no particular staff behavior. The only difference is that these algorithms are aware of the exit locations, the doors, the nearby doors. So using that, they will try to escape themselves, but they're not the best algorithms available. So this is going to be the final results, and we can see that zone sweep has performed one of the best, apart from PSO obviously, and even staff all assist and top evac, which are almost the same kind of algorithms, have performed better. So comparatively, when we see it in chart, I think it's even more better to understand that zone sweep is performed the best, and staff all evacuate as expected has performed the worst. Both staff assist elderly and assist mobile. Um, since they're very selective, I think these are performing very poorly because there's a lot of chaos with the selection of staff. I mean, the selection of pedestrians by the staff, and avoid top and all of the others are performing fairly equally. So that's something that we can get from this graph. And if we see the comparative and performance of other algorithms, we see that random is the poor one, because it's just random. We don't expect it to perform evacuate that much, and PSO is expected to evacuate every pedestrian out there, because everyone is a pure PSO agent here. Um, we can also note that ACO SFM and the vanilla SFM perform almost equally, and MFO SFM is not that great. I think these can be worked on in the future. Um, but on a comparative note, the best algorithm or the best staff policy with PSO SFM has evacuated 114, while here it's just 60 with pure SFM, which is a good improvement that we can see when we've added staff policies or staff agents within evacuation strategies. So I'll see you on the next video. Thank you.